So once again, good morning, students. So what we are going to discuss is the lecture 3 of Data Science and Analytics module. So here we are talking about pre-processing and feature engineering, right? So last week's topic, of course, is very kind of interactive one where you have to do things likewise. But this one is a little bit of theoretical, but that doesn't mean you don't have to do anything, right? So you will, when you are doing a research sort of thing, you have to do this process is very, very important. It will affect your results, right? Let me open Jupyter Notebook as well. Why? Because I have some demos there. I hope you know Jupyter Notebook, right? So you are doing labs with it. It's a very useful software and free also. You can download it from internet and you can use it. You don't need admin permission or whatever. So you can use it, right? Of course, in your machine, you might have admin permission. So that you can do. So what we are going to discuss under these topics is, student, there are issues in data. Now, all of these, now we talk like we want to find out pattern, forecast, those, all of these, it will be difficult if you have issues in data, right? So when you have issues in data, you might have to do data cleaning, right? Then there are other things you might have to do. This is not necessarily issues. This is like if you want to improve your data set. Improve your data set, you might have to do this, right? Other thing is you have to do some transformation as well. So what is data transformation? We will see, right? Okay, so let's look at these outcomes. Outcomes means what is you should be able to do at the end of the lecture. So you should be able to tell, look at a data set and tell, okay, this kind of pre-processing is required. And the other thing is select a suitable feature extraction method to improve efficiency of your data analytics. That also you should be able to do, right? So now let's start the lecture. So here it says, now we have to think about data, right? Data are observation of real world phenomena, right? So something like what is happening at the moment, you can find out using this data, right? For example, you have personal biometrics, like you have heart rate, blood sugar, blood pressure, that gives you indicator like what's going in inside your system, right? So that kind of thing is, it's giving a observation, right? Observation of real world phenomena. Each piece of data provides a small window into limited aspect of reality. For example, if you have weather, now weather, like you can have, let's say, wind speed. This one give you a limited window. About certain reality, it gives some indication, not everything. Everything you can't determine using wind speed, right? Right. The collection of all these observations give you a picture as a whole. As I told you, wind speed, if you want humidity, if you want rainfall, likewise, then you can get a big picture as a whole. However, so to get this big picture, you need a collection of data. But however, those data really don't come in the shape necessary for data analysis. So it might have several issues. Like what? So what you can see are examples in the next slide. Some data is incomplete. Incomplete is like, as I told you, if you take a weather example, let's say wind speed, unique wind speed to check the weather, but wind speed column is missing. That is lacking attribute. Data set is incomplete then. Attribute is lacking. Other thing is you can have lacking certain, this is lacking attribute. This is lacking attribute values. Sometimes wind speed column is there, but you don't have data. Not only wind speed, let's say humidity, rainfall, here and there in the data set, there are some values which are not there. That means incomplete. Sometimes you might have only aggregated data. That means you want, let's say, daily sales, but you have only weekly sales. So that is also not acceptable. Right? So in that case, your data is incomplete. So your daily sales data is missing. So you have such things. Right? Sometimes data set can be noisy. Noisy in the sense you might have errors and you might have outliers. For example, if you want the GPA to be between 0 and 4, but you have a GPA value for 10. Not possible. There is an error and outlier. Right? So that kind of thing is going to negatively impact your data analysis. Right? And there can be inconsistency. For example, someone gives you age as 42, birthday is this one. 2010 you can't be, it can't be 42. So that kind of thing can be happen. That is inconsistency. And there might be rating. For example, rating column, some people have put 1, 2, 3, some people have ABs. Again, there's issue, right? So this kind of things, students, are really there when if you look at the data set. Now these are next year you are going to do a research now. So if you are doing a numerical data set, some people are doing, let's say, my own student group, one student group is trying to predict the credit card payment behavior. Then last year, one set of students did a research on how employees progress within organization, predict like when he will get promoted. So in that case, you have a large data set, right? In that data set, you can have these issues, right? So you have to, when you have issues like that, you have to address these issues. Otherwise, you might get into trouble, right? Because some data analytic techniques can't proceed with this. Some people can proceed, some will give you erroneous kind of results, right? Bad results, right? So that's why we have to address them. So what is data pre-processing? It says that data pre-processing, as the name implies, involve curating the data and make it suitable for data analysis. So you are going to address the issues and make it suitable for data analysis, right? So common things, you might do data cleaning. In that case, you might, you are going to do some incomplete data, you might remove in outliers, you might address, and inconsistent data, you might make it consistent. And you might do data transformation and discretization as well. But this is not exactly a cleaning process, it's a transformation process, right? So that is what these are two tasks we are going to complete. Apart from that, today's lecture, we are going to discuss feature analysis as well, feature selection, right? Okay. Now, students, this lecture we have to, because we have to do it beforehand. The order of this unit should be pre-processing first. Usually, that is the cycle. No? When you get a data set, you start with data pre-processing. But when you read this, because you will feel like this is theory. But when you go to the next few lectures, you will see how really these things are applied. So for the time being, if you are, you might feel this is a theoretical lecture, but this is very, very important step in your data analytics procedure, okay? Right, so first we'll talk about incomplete to missing data. So sometimes missing data in the sense, sometimes a column might be missing, sometimes row can be missing, right? So missing names, missing values, as the name suggests, are values we expect, but we don't have it, right? In simple terms, missing values are empty cells in the data set that we want to use. We want to use it, but you see empty cells, empty columns also, right? So why with this happens? Sometimes it's a human error, right? When you are typing in, you forget to fill one blank. That usually happens no? If you are filling large data set. Or if it is a survey, sometimes what you do is you do a survey data and you transfer. You can use something online survey tool like SurveyMonkey or whatever. Even with Microsoft Forms, you can do. And you convert it to the Excel sheet. And you want to do it for analytics, right? So then some response might not answer. For example, if you ask your salary, some people don't like to tell it, right? So that person don't give the answer. In that case, that cell is empty. Then person taking the survey does not understand the question. Usually that happens, right? Even us, if you are given a question in the final exam paper also, if you don't understand the question, you skip, right? That is what you do. No? So that can happen, right? The provided value is an obvious error, so it was deleted. So let's say you get a value from someone and you find GPA is 10 and you know it is an error, you delete it. So then you have missing value in the data set, right? If you are collecting data using equipments, you can have sensor malfunctions, or if you are running it, you see generating data using a program, sometimes there can be an error in the program. So because of all of these, you can have missing values in your data set, right? So let's see now, if you have missing values, what you can do, right? Okay. Now, before you go to that, students, so you have to identify the pattern of the missing values. That is very important. So we have three types. Can you spend a moment and read this one? Spend a moment and read this one. Okay, went through. Right. Example, missing completely at random. With MCAR, there's no relationship between missing data and any other values observed or observed within the given data set. The fact that it is missing is independent of the remaining variables, right? What I will do is, students, I will start from the second one and third one and come back to the first one later, right? So missing at random, when data are MAR, the fact that the data are missing is systematically related to the observed, but not to the unobserved data. This means missing values can be explained by variables on which you have complete information. So can be explained in the sense you can't really predict it. So what you can, let's take about, okay, you ask for someone's designation, right? Someone's designation and you have salary. Both you have in the data set, right? Now someone, let's say, someone, now so there might be people who are not working. Then they don't have salary, right? So what you have is, so this designation might have missing values because it's related to the other data. Is it clear? It's related to the other way around, right? Salary, you have missing data because it's related to the designation. There's no designation for that person. Because of that, salary value is missing. So it's related to the observed data. What you have in the data set, it's related. So that's why it's missing. Is it clear, students? Is it clear? Is it clear? Only one response. Right. Okay. There's a request to explain it again. So what it says is, when the data are MAR, the fact that the data are missing systematically related to the observed. Observed value means other variable values, right? Other variable values, but not to its own values. In own columns value. Now I said, so you are asking for designation and salary, right? So what if there's some person says designation is he is not working. Not working. Is it clear? In that case, do we have salary? So this missingness is related to this, right? Do you understand that? He is not having a salary, that's why it is missing. Is it clear now? Okay? Right. Okay. Right. Let's look at MNAR. MNAR, missing values dependent on unobserved data. That means its own values missing, there's a reason. For example, you are going to ask, do a questionnaire about depression. Right? So you ask a depressed person, are you feel depressed, right? So there's a depression column. People don't give value for that. What is the reason for it? The column itself, this issue itself, right? Because he is depressed, he is not giving value for that column. That column itself, is it? Here not like this, right? Here salary is not given because he don't have this. Now for this column itself, he is not giving a value because he is depressed. Is that clear? Is that clear? Is it clear to you? Here we are talking about two columns. Salary and designation is there. Missingness of salary is related to this. Is it clear? Here we are talking about depression. Missingness of this value is it's related to itself. Because he is depressed. Now is it clear? Missingness of values in here is related to that column itself, not to other thing. He is depressed. That's why he is not giving. Is it clear? Let's say you asked an overweight person, right? You are asking a weight of a person. There's a column called weight. So overweight person is not giving that value, for example, because he don't want to others to know. So what is it related to? That column itself. So you have a weight column. And people are not giving values for this weight. That is not because of any other thing. Because this value is larger. Is it clear? Is it clear?
Yes.
Right. So sometimes, let's say salary. Some person don't want to give the salary. Why is that? Maybe his person is too high He don't want others to know. So missingness is related to itself, right? Because his salary value only, he is not giving the salary, right? Okay, I hope it's clear now. Is it clear, the students who raised the question? To explain it again, is it clear now? Is it clear? Right, okay. Now this one, MCR, nothing like that. MCR, it's not related to itself or it's not related to other value as well. So for example, let's say you ask height. Okay, height, some people might not give height. Let's say if you give temperature, not temperature. If you ask someone human value, let's say height, right? Height is not usually, unless someone is very short, they might not give it. So height, this value is not related to another value, and it's not related to itself also. If it's missingness is completely random. It's not related to other value, or it's not related to itself. Is it clear? Is that clear? Understood? It's not related to other value. It's completely random. It's not missing due to a certain reason. Now, if I give it like that, it will clear things now. It's not missing due to a certain reason, not because it's related to another one or something like that. Right, okay. So let's see what are the, now if you have missing values. Yeah, yes, name is normally not a numerical value, but what you are telling is correct. If you give name and address, people might not give it, right? People might give it. There's no impact of it to other or something like that. So name might be a example for MCR, but only thing is something like name you don't use for data analytics. It's like it's not a numerical field. So name is not usually anyway. Yeah, the example is correct, but usually you don't use it. Right? Correct. What you said is correct. Right. So if you have missing values, what should you do? One thing is you keep them as it is, you keep. You don't do anything. Basically, you don't do anything. That is a good student. If this sometimes some data analytic techniques are there, they can handle missing values. They don't mind missing values. In that case, it is okay to keep them. So we will, as we go through this lecture series, you will know what kind of things are there. But sometimes if you feel these data values, it might going to be missing values, some data analytic techniques, you don't have to, you have to remove missing values. In that case, you have to leave it out. Right? So that is one. Then you might have to remove the data object with missing value. That means you are removing the rows. One observation, one survey, one person survey, you are removing. Let's say something like that. That is removing data object with missing values. You can do it, students, but only thing is here it says, should be careful not to introduce bias into the data set and removing valuable information from data. So let's say, okay, let's say you are, what is that? Okay, let's say now generally, you know, students with first class is not, there's not a large number of students with first class, right? So if there is missing values with, now you are going to do a data analytics and you have the class also. So you have first class, second upper, second lower, and general degree. You have things like that, right? Let's say you have it. So first class, let's say there are only 30 people. Out of that, if you remove, if there are 15 which is having missing values, you remove 15, means this data set is going to be lower, right? It's going to be lower. In that case, you might not correctly conclude related to these rows because this class, this set of subset is low. So because of that, you might need, this is biased now. Now it's biased. So let's say people with general degrees like 1000. Here you have only 15 rows. So then you can't correctly analyze this. So that will include a bias for this data set. Right? So missing values in a data set that are type of MNAR and MAR data objects with missing values should not be removed because they are there for a reason. Right? Missing values, you know, it's not completed at random. It's not totally totally independent. It's not a coincidence. Right? So here it's missingness is there for a reason. people don't like to give it. As I tell you, depressed person doesn't like to give, he is depressed. So that is this. Sometimes the salary you don't give because of the designation. So then there's a relationship. So in that case, if you remove the data, what will happen is you are going to lose some important information. So that case also you might not do it, right? So when you are removing the rows, you have to be careful. Another thing you can do is you can remove the columns. Your entirely column you can remove, right? If the so for example, I will not go in these order streams. I will tell you. So usually if attribute is having more than 25% of the missing value, let's say there are 100 rows in a column, and in one column 25 of that is having missing values. That means 26, let's say, more than 25%, then you can remove it. More than 25% missing value in a row, in a column, in one column. If 25% more than 25% data is missing, you can remove it, right? But however, you have to make sure that it is absolutely not absolutely essential. It's, let's say there is a column, but it is the main variable which is affecting what you are trying to predict, right? Is it clear? So in that case, you can't remove that now. You can't remove that, okay? So then if it is absolutely not essential only, you can remove it, okay? Right. So when the most of the missing values in a data set, you are removing attribute that I told you, right? So, right. So that is one way. Another way you can do it, you can estimate and impute a value. That means there are data analytic techniques. Even if you go to SPSS, as far as I can remember, SPSS, this is there, right? You can do a imputation. That means you can fill the missing values. So how does it fill it? There are tools for that, right? Tools there. If missing values are of the MCR and MAR, you can do it. So completely they are not related to other. So in that case, you can impute it, right? Imputing, that is how we call it, right? Impute. So there are several techniques, students, but there is regression analysis, interpolation, likewise. But this is easy to understand. So what you can do is, so if there is a missing value in that column, you have mean value, no average value, you can fill it there. Okay, right? I will show you example. Where is it? Yeah. Right. So here I will just run everything. I think I might have the run example. No, yeah, I have it, right? So this is students AR data. AR data is this one. I think for your lab sheet also you have this. This is not clear now. So let me go and show you. Yeah, the data set actually. Actual data set. You can see some missing values are here. Here there's a empty cell. Empty cells are there here and there. There's empty cells. Here I think there was two. One is missing here. Here missing. Right. Some place I saw two missing values. One is missing here. Other one is missing here. Like this. So you have here and there missing values. Okay. So then what can you do? First thing is okay. Look at this. Right. Sorry about that. Right. In the analysis. You will learn these things, students. You can learn these things when you go to you might have a practical. You are going to have a practical test. So there I don't want you to remember the coding, but you should know the theory. Yeah? Coding, some codes you have to remember. Codes you can get it from anywhere, but theory you have to remember. What are the steps you have to do, right? Okay, so here this print data set likewise is there. Describe is there. I'm not going to explain these because these are for labs. So this is giving you an overall of what is the content of your data set. You can see the mean value, likewise it's there. And you can see it's the first thing you do is you drop the duplicates, duplicate rows you have. If you can drop it. And here, over here, yeah. over here, using a very simple command in this Python, you can get the number of missing values. You can see here in this data set, temperature, humidity, wind speed, wind direction, no missing values. Right? Yes, is there a question? Yes, you will get the lab recording if you miss. Only thing is, there's a faculty policy that it's going to be it's only be updated after 2 weeks. That's because students don't come to the labs. Right? So you are relying on it and you are not skipping labs or something. There is something like that. So because of that, we are going to a little delay so that, okay. And students, you know, if you miss one lab, you can go to any lab, right? That you all know. Me. If you miss one lab, so you can go to, again, there is one student with one student with name. So I hope you have seen my message, chat message. So attendance will be not taken. I'm not going to put your name. ABC is attend for this session. I can't put like that. No? We are recording attendance using student ID. Right. So this much of, so as a column, this is a count student. It's not a percentage. When you give this sum, this is very, you see how, why Python is used for data analysis is like, you can, now what is this? This is my data set. I am going is null sum. It's going to give you with that command, it's going to give me that. Have you used Python in any other lectures? Python, are you using in any other modules in your student life? Yes, right? Is it DSA? DSA is done using Python? DSA means the other DSA you have, second year DSA. All right, okay, then you know, right? So here is the percentage of missing values. Here 6% is missing in this particular column, right? So there is no need to drop the column. And otherwise, maybe this is a very important column. So we don't need, there's 6% is okay. What you can do is here, now students, after that, you might have to find out what is it MCAR, MAR or MNAR? So this is actually not a complete example. What has been done here is, students, so you see whether now this value, location B, location B, you want to check whether its missingness is related to other. So what you do is, with the missing values, you plot the box plot. With the not missing value also, you plot the box plot. If they are related, when one is missing, it should have a huge impact on the other. So here you can see, for example, this is with missing value. You are temperature column with the missing value of location B, temperature values with not missing value of without missing value of location B. So in that case, you can check whether missingness of temperature is it because of missingness of location B, is it because of temperature? That relationship you can find out when you plot like that, right? So in this case, you don't see a big difference. Yes, there is some difference, but you can see a general shape is same, right? So you have a shape like this, right? So in that case, but this is not you can't give a conclusion answer using this, because here I'm checking only temperature again, location B. So you have to check each and every attribute, plot each and every attribute and see, is it, why is this missing, right? So once you find out if it is MCAR or something, you can impute. That is exactly what is done here. So here what is done is, the null values you are replacing with mean. Mean of that location A and B, both columns are having missing value. Both missing values are replaced by its mean. Right? Very simple command. Now you can see location A and B, missing values are now gone. There's no missing values. Right? A and B, no missing values, 0%. Is it clear? Is it clear, students? I hope it's clear, right? Okay, good. Right, let's move back and let's look at outliers next. So what is outlier? Outlier is the extreme point. So if you have, let's say, usually if you have height attributes, so you expect something like 5 between 5 and 6, right? For a person's height, you can't have more than that. Let's say 6.5 or something. 6.5, 5 and 6.5 or 4.5 to 6.5, you expect something like that. So if you have something like 7.5, that is extreme, right? That's outlier, right? So outlier or extreme points are data objects whose values are too different from the rest of the population. That can happen, right? Again, it can be due to errors as well. Huh? Sometimes it can be due to errors. So outliers could occur due to errors in data, and outliers that are errors can skew the results. It can negatively impact the results, right? So some analytics tools are sensitive to outliers. For example, we will learn k-means algorithms next week. If there are outliers, this answer will totally change. So in that case, so you better have to look for outliers, and if there are outliers, you can remove it. So outliers can be univariate outliers. That means within one column there are outliers only. So height column only. It's extreme. Let's say univariate. That kind of thing you can identify using box plot and bar charts. So if you draw a bar chart, you might have things like this, and somewhere over here you are having another one, and nothing in between. So that is outlier that you can identify. Sometimes there are bivariate outlier. There's a person with extreme height and extreme weight, both by two variables. Across two variables, it is height, right? That you can identify using scatter plots, contingency table, something like that you can identify. If you have multivariate, that means across not only something like height and weight, other ones are also extreme, other columns. That kind of thing you can identify using cluster analysis, right? So some pictures are given here, students. So for example, when you draw this, you know how to draw a box plot, right? You have done it in PS now. So you can see here after the usual, the maximum value, the values are there. Not the maximum. After the, you have the what do you call the, like you are, what do you call it? The upper cap, you have values. So that kind of values are these. That is extreme. Here you can see an extreme value. Usually tendency is like this, and you have something over here. This is a bivariate, weight and height. So as I told you. So this is a bivariate out. And contingency table also you can find out. Okay, you can find out which one is having the lowest extreme ones. That you can find out using contingency table. This is if usually if your variables are categorical. Now what is, okay, before we proceed, students, what is categorical and numerical? What is categorical, students? I should have included a slide for this. Categorical. Categorical is if you have high, low, medium. Likewise, you have columns. So that kind of is categories, right? Numerical is something like height and weight. You have numeric values. So that is numerical. Okay. Right, now cluster analysis, this is of course, it's drawn for 2D, but cluster analysis, it can identify across 3 columns also, 3 axes also, it can identify if there are multivariate types. Okay, so in here, I have a small demo for this one as well. Here you can, I hope you know IQR likewise, interquartile range box plot. When you're drawing it, you draw it using that, no? Right. Okay. Then here you can see. Yes, this data set is look at this one. Only thing is, students, there is lower bound and upper bound is considered as three distance away from the Q1, both the axes, right? Okay, look at this one. Study this one for a moment. Now you can see here, this column, humidity. Yeah, humidity is this, you know. humidity Q1. You know Q1 and Q2, right? Q1 is 56. Q3 is 78. So IQR is what? Q1 minus Q3 minus Q1. So that means it is 22. IQR is Q3 minus Q1. This is 22, right? Then how do you get the lower bound? That you can decide, right? Lower bound is given as, you have IQR, 3 distance of IQR away from this. That means 3 distance away means 66. No? 56 minus 66. So IQR goes like this, right? So this is your Q1, this is your Q3. What is giving is upper bound is 3 of this distance away from this and away from this. So mine, that means IQR is 3 of IQR is 66. No? 6. So this is 56. This is 78. So you have to have 78 plus 66 and 56 minus 66. So the 56 minus 66, of course, minus 10. Here minus 10. 78 plus 56 is 144. So your lower bound and upper bound is this. But student, if you get the maximum, what is it? This is okay. This one is okay actually. If you look at another column, this is okay because this maximum is within the upper bound. But if you look at this one, for example, upper bound is 42, but maximum is 65. Then after this, you have values. These are outlier, right? If you look at even this row, upper bound is 84, maximum is 116. That means after the upper bound also, 3 interquartiles range away from the Q3 also you have values. After that also you have values. Is it clear, students? Is it clear? Is it clear how you found out these outliers? Yes? Right, okay. So once you plot it, of course, you can identify also. Let's clear the drawings. If you go down, here you can see there is outline. There are outlines. After the Q3, Q3 is here, upper bound, and you have this outliers over here. Here, of course, you can't exactly find an outlier because if you had something extremely away, let's say something is there, you can kind of see it as a cluster. But if you had something like a way like this, maybe a way like this, you can see identify it as a outline. Okay, right. So let's see. Now you know how to identify outlier. Then let's go to the slide and see what you can do when you have outliers, right? Again, if your analytic tool can handle it, you can leave it as it is. Do nothing. Or you can replace with upper cap and lower cap. That means, for example, these upper bound values. So where you have this one, yeah. So this maximum value you had, the one with the 116, you can replace it with 84. Maximum value is 116. It's an outlier. No? You can replace it with 84, the upper bound. Then it is in the acceptable range. You are bringing it down, right? Bringing it down. That you can do, right? Then removing is also possible. You can delete it. Delete the whole row. That is possible, right? Okay. So that is one. Now, the next topic is data reduction. So you want to reduce the size of the data. Why? Because students, you will see. So when you have a lot of data to analyze, your processing power is not enough, right? If you have something like GPU or high processor power, that you can do, but usually your processing is not enough, right? Sometimes students, have you heard about Google Colab? Have you heard about this? Anyone who heard about this? No? So visit this site and see. Here you can anyone here? No, okay, good. Good in the sense it's not good, but you are now learning it. That's why it's good, right? Right, Google Colab is something you can make an account and do data analysis. You can get resources from there. So in that case, the processing is not done your end; it's done in the server side. It's not in your. It's done in the cloud, right? You can select a GPU and you can do. Only thing is there are time limitations, right? Because multiple people are collecting in, you will not be getting infinite time. So it's a good tool if you want to do when you're doing research. Many students are doing it because of the lack of resource. Lack of resource, many people are doing it, right? Okay, then high dimensional visualization. So why do you reduce size? One thing is because reduce size in the sense, students, it can be reducing number of rows or number of columns. We will see that there are two types. You can reduce the number of columns or you can reduce the number of rows. So why would you do that? High dimensional visualization. When we have to pack more than 3 to 5 dimensions in one visual, we will reach human limitation of comprehension. So if you have columns, now you want to find out outliers or something, sometimes you would like to visualize, right? So, but you can, if you up to 3 axis, you can just visualize, right? Up to 3 axis, you might be able to visualize. Only thing is beyond it is beyond your visualization. So if you want to visualize it, you might try to reduce your number of columns. So if you sometimes in real world, you might have hundreds of columns to process, right? So you might not use all of this. Okay. Then you might want to reduce the data set because you have very large data set and its computation cost is very high. It's taking a lot of resources and time. So because of that, you might want to do a reduction of data. Your data set you want to reduce, right? And the curse of the dimensionality. Curse of the dimensionality means, students, so let's say you have 100 columns in your data set, but there are only 20 rows. So sometimes you can't come to a conclusive decision using this because the lack of the data rows. And in that case, you might try to reduce the columns, right? So here it says, some of the statistical approaches become incapable of finding meaningful pattern in data because there are too many attributes. So too many attributes, but the rows are lesser. So in that case, you might have to reduce the number of rows. So when we talk about data reduction, students, there are two things you keep in mind. Here it says there are two objectives of the data reduction. First is data reduction seeks to obtain a reduced representation of the data set from much smaller value. So you want to keep the reduced representation. That means it's not like you just take, okay, half of these data I'm going to take. So for example, you have a huge data set, we will say, you are going to take only first half only. That is not a good technique. Why is it not a good technique? Let's say a particular class is at the end of your data set. For example, you are getting data, let's say district. District wise, you are collecting data. So Colombo district, you get 20, let's say 100 data. Gampaha district, you get 100 data. Likewise, you get, right? Kalutara again, you get. Kandy, you get. Likewise, you get 100 data from each district. So if you have your data is going, if you remove the, let's say Colombo is first in your data set, Gampaha is next, likewise. So if you take the first half only, maybe you have only Western Province data. Other half is missing. That is not a reduced representation, right? Reduced representation is if you take 20 from each of these, then it's a good representation. Smaller volume, good representation. Otherwise, if you randomly select, you might get into trouble. So we will see what are the ways you can do it. Secondly, it tries closely to maintain the integrity of the original data, which means making sure that data reduction will not lead to including any bias. So you have to maintain the integrity between original data. So you are not including bias to that. Certain, as I told you earlier, if you put only Western Province data, it's going to be biased, right? So you have to maintain the integrity of the data. That's the correct representation, right? Okay. Now, students, there are two types of data reduction methods. One is numerosity data reduction. Here what you do is you try to reduce the number of rows. Data objects or rows. Then you have dimensionality reduction, where you are trying to reduce the number of dimensions or attributes. So what is dimensions? We will see. And attributes. So these two are two things: numerosity reduction and dimensionality data reduction. Okay, right. So what is numerosity reduction? What are the techniques? You have these techniques. I'm sure you have heard about these, students. Have you heard about this random sampling? You have, no? Yes, probably you have learned it. What is random sampling? So let's say I want to think about what people think about the QR code. Right? So what I do is I go around and find out from every district. I'm going to randomly select people and I'm going to get data. So that is random sample. I can't apply this for the whole population. Whole population means I think there are vehicle owners according to 60 million or something like that. No? So likewise, so I can't do that for everybody. So I'm taking randomly selected. Right? So what is stratified sampling? Randomly selecting, now why do you do it? Randomly selecting some of the data object to avoid unaffordable computation cost. That is anyway the purpose of sampling, right? Here, randomly selecting some of the data objects to avoid unaffordable computation cost, all the while maintaining the ratio representation of the subpopulation in the sample. So what do you mean by that? Subpopulations, you have to have the representation you have to maintain. That means, if I'm talking about QR code, there are different subpopulations. There are people with cars. There are people with motorbikes. There are people with three-wheelers. There are people with buses. So if I have to consider all these subpopulations, right? Not just selecting random person. So sometimes when you select random person, maybe we'll say at the end of the day, what you have is only people who have cars, not the others. That is not good enough. So what you should do is you should consider all the subpopulations. Ratio should be maintained. So that means if there are three-wheelers, let's say 3,000, cars is 1,000, and let's say, what is it, motorbikes you have 2,000, this ratio should be there in your sample. That ratio you have to maintain, right? Is it clear? Right. So here it says randomly under and over sampling. Randomly selecting some of the data to objects to avoid unaffordable computational cost. That is correct. That we have talked about in every sampling method. That is what we have found. All the while creating a prescribed representation of subpopulation in the sample. That means, students, you should have a balanced data set, right? So, for example, if I have like here it's now let's say I have a lot of rows with cars. I might have to delete some of these. I have collected all the information about a particular district, and if I find cars is the maximum, I might have to delete some of these so that my data set is balanced, right? Then I might, if I find that let's say three-wheelers, I have got only few. I have, let's say, 200 data sets. I have only 10 three-wheelers. Then I have to somehow increase this row. You looking at the existing rows, I can do some changes and generate new rows, so that my sample is in the prescribed way, right? So because if you have low number of rows, your analysis might be wrong, right? I hope it's clear to you. So this is about numerosity reduction, mean reducing the number of rows, right? So our next topic is dimensionality reduction. This is about reducing columns. Okay. Shall we have a 1 to 3 minutes or something break, students? So let's have a break, right? Anyway, I don't think I will, there's no much slides, But let's take a break anyway. 3 minutes or 2 minutes break. Okay. Do you have any questions up to this? Do you understand, students, that this is a very important topic? This is very important. Huh? Sometimes students, when you come with accuracy issues, likewise, when you look at into that, you will find, especially this, which are feature selection, what we are going to discuss next, accuracy of your models might be lesser, right? Okay. So let's take 2-3 minutes break, right? Otherwise, you might not be able to absorb it. Okay, now let's talk about, students, about dimensionality reduction. Now here what you do, anyway, let's talk about what is dimensionality first. So here it says the number of input variables or features for a data set is referred to as dimension. Number of features in number of, now students, these are data analytics terms. Features are columns. Number of features is considered as dimension. Dimensional reduction is used to reduce the number of attributes in the dataset. More attributes often make predictive modeling task to more challenging to the model and generally referred to as curse of the dimension. As I told you, if you have a lot of rows, a lot of columns, but lesser number of rows, conclusive decision can't be drawn. It's very difficult, right? So that is why you might go for data reduction. It's dimensional reduction. Now, dimensional reduction, students, there are two methods. Again, one is feature selection, other is feature extraction. These two are two things, right? Feature selection means you are trying to find out the most relevant subset of input variables. That means, so you want to predict something, let's say for X. So you find out which attribute is best to predict this. Some of these are not very important, right? For example, so if you are trying to predict your grade, what might be a good indicator of your what can I use to predict your grade? The main thing is your effort. Main thing is your effort. Other things like your IQ likewise will affect. That's not a matter. So if I say, for example, the power interruption, does it affect your performance? I don't think so. Because if you have a power interruption, you can join another lecture, right? So likewise, so just an example, right? So likewise, you have to find out what are the best variables you need for this data analysis. That is feature selection. So there are methods, feature strategy, wrapper strategy, embedded strategy. Likewise, there are strategies for these. Right? Feature extraction means, students, here it says feature extraction converts the data in high dimensional space to one with lesser dimension. Another thing is, you find a small set of new variables, each of which is a combination of input variable. That means, here what I'm going to do is I'm not going to eliminate variables. I'm going to, in this case, I might combine some of these. So I might combine these two. I might combine these three and come up with new variables so that now my number of columns is lesser. Is that clear, students? Is it clear? Is it clear? This is actually nothing difficult, right? Right, let's look at these filter strategy, wrapper and embedded strategies a little. Filter methods. So filter method, students, you use generally as a pre-processing step, because some of these methods are actually some of these feature selection methods are in the method itself, analytic technique itself you are using. But this is totally different. That means analytic method and this method, there's no connection. What you do is you do it separately, right? So the selection of features is independent of the machine learning algorithm. This is something you totally do in the pre-processing stage. Instead, features are selected on the basis of their scores of various statistical relations. So here you have feature and response. Feature, I already told you, column. Response is, let's say, target. So for example, if I'm trying to predict my rainfall I'm going to predict using temperature, wind speed. So this is my features. This is my target variable. So if now there are different tests. For example, you can use Pearson correlation, chi-square, LDA, ANOVA. Like this, there are so many methods. It depends on the type of the data. For example, if you have two continuous variables, that means like rainfall is continuous or numerical. Here you have wind speed likewise also are usually continuous variables. In that case, you can use Pearson correlation. Sometimes your target is going to be categorical and your feature is continuous. In that case, you can use LDA. Likewise, there are methods you can use. Right? I will show you one example. Okay, using my demonstration. Yeah. Feature selection, yes. Okay. Here, students, what is given? What variables? There are many. There are many variables here. You can see crime, likewise, number of age. Okay, there are so many things. I am not going to explain of this. This is the target variable. In this case, this is the target. Others are features. These are features. This is the target. Now you have to think about, now both are continuous. You can see all are numeric values. All are numeric values. So in that case, you can use Pearson correlation. So here you can see students in the next, when you scroll down, the correlation matrix. So you can see here, darker it gets, the correlation is higher. Now you have to, now this is our target variable. So which variables are highly correlated? Let's say if you consider 0.5 as the cutoff, which one are highly correlated with this? Which one? This one is highly correlated. 0.51. This one is highly correlated. Others are probably lesser correlated, right? Okay, this one is also there. 0.7. So you can see these are highly correlated with this one. So other ones, you might not necessarily need it. For example, you can see here 0.18 is a very lower score. So it might not really correlate with this. Actually, there are slides. Let's go to the slide, complete and come back. Okay, so here it's about the chi-square test. Chi-square, as you have seen. So what is chi-square? Chi-square you can use when your target and feature and target are both categorical variables. In that case, you can use chi-square. So is generally used to test the relationship between categorical variables. It compares the observed value from different attribute of the data set to the expected value. Expected is target. So different attributes you compare with the target, the chi-square value, then see. And you compute p-values. So you will see this when you go to the lab students. Lab sheet, there's an example on this as far as I can remember. Right? In the test, chi-square between each feature and target is obtained and the desired number of features which has the best chi-square is selected. That is what you do. But chi-square, there is a requirement, that is that variables, of course, have to be categorical, sampled independently, and the value should have an expected frequency greater than 5. Each value should have a frequency more than 5. So that kind of limitation is there. Let's go to the next one, our Pearson correlation, the one which I wanted to show you example. Okay, read this one. There are a lot of things here. Read it and read this one and see. So, correlation is going to, it's going to vary between -1 and 1, right? Read it for a moment. Okay. So this is Pearson correlation. is a measure of quantifying association. Anyway, you know that correlation you have learned. So it's giving a level of association between variables. That is what it is giving, right? Through correlation, we can predict one variable with other variables. So sometimes you can say, okay, there's a correlation between the number of hours you study and let's say number of hours you study and your mark. So one is increasing, other is also increasing, something like that. So there's a correlation, right? The logic behind using correlation for teacher selection is good variables are highly correlated with target. So if your variable is now, for example, numbers of hours you study, it might be highly correlated with your the mark you're going to get. Not something like another variable. Let's say number of power cut hours, right? It might not be very correlated with your grade, right? So that in that case, you are going to remove the ones with the lesser correlation. Furthermore, variables can be correlated with the target, but should be uncorrelated of themselves. Now, for example, if you want to predict the rainfall, let's say let's say, so rainfall you want to predict, right? So you have humidity and wind speed, right? So these should be highly correlated with this one, but should not be correlated with this one. Then there's no use if they are highly correlated. Why do you need both then? These are correlated mean one you can predict using the other. Then both of them are not needed, right? So if two variables are correlated, we can predict one from other. Then if these two are highly correlated, why do you need both of them? Because using one, you can predict the others. Therefore, if two features are correlated, the model really needs one of them, as the second one does not add any additional information. So, right? So look at this, what we are doing in this this exercise. As I told you, these are highly correlated one are these, right? I can't see what they are. Let's see. Yeah, you have this RM, whatever I'm not quite sure what is RM. RM is there. PT ratio is there. PT ratio and LSAT. LSTAT are the highly correlated one. So let's look at this and you can find them out. So here it says the same thing. This last one is the highly correlated, even it's highly correlated with the target, that is the target itself. So you don't have to consider this. So taking as the 0.5 as a cutoff, you can see these three are highly correlated with the target variable, right? So then what is done here? Look at this one. What is done there, student, is what? What is done there is you are checking whether is there a correlation between them, right? Correlation between them. Now, this LSTAT and PT ratio, is there a correlation? Then also you can remove them. So you can see this LSTAT and RM, there's a highly correlation, 0.6. So in that case, you can remove this and you can only consider what variables. Now, first one is correlating with target variables. We found 3. Then we found these two are highly correlated. This one and this one. Then out of, you don't need both of these. You can select one of these. Is it clear, students? Is that clear? Is it clear? Is it clear? No response. What? Right. Only few people are responding. So what is done is, if you, okay, so, right. So please go back and read this one. Read the slide. Read the slide and see. After that, I will explain. Read this. Sorry about that. Read these 3 points. This is the essence of it. So what does it say? First thing is, you select the features with a highly correlated with the target. Now here in this case, target is this MDev, right? This one, highly correlated ones are, I have got the threshold as 0.5. Highly correlated ones are these three. Is that understood? Next, what it says? Next, it says, furthermore, variables should be correlated with the target, but should be uncorrelated among themselves. Therefore, if two features are correlated, the model really needs one of these. So, one thing is they should be highly correlated with this target, that is these three. But if you move down, you will see, although they are correlated with the target, they have correlation between themselves. In that case, you don't need both of them also, according to the slide. According to theory, that's like that. So these are correlated among themselves. So you don't need both of these. You can remove one of these. Is that clear now? I hope it's clear now. Okay. Right. So we'll continue to wrapper method. So wrapper methods, here it says wrapper method. Now we have what are we talking about? We are talking about feature selection methods. There are three. One is filter methods, other is wrapper methods, other is embedded method. Filter method we discussed, Pearson correlation, likewise that. Now we are talking about wrapper method. Wrappers require some method to search all possible subset of features, assessing their quality by learning and evaluating a classifier with that subset. Right? So what you do here, student, is you generate a subset. You have all the features. Let's say X, Y. Sorry. Let's say A, B, C, D, E, F. Likewise, you have all the features. What you do is you take one subset. Let's say AB. There is a order to do it, but just for the sake, let's say you take AB. Right? Then what you do is you train using AB. You run the model using AB and you evaluate performance. Then you next try with ABC. Right? And you again run the model and check the performance. Likewise, you find out what is the best selection. Best combination of features, right? So there are two ways to do it. Read this one. This is very easy. Read it. Forward feature selection and backward feature selection. So what you do in forward, you first find the best performing variable. So again, a question I got it weekday when I doing this is, how do you find the best method? So actually, students, when you try the model using A, B, C, D, E, individual variables, you can find what is the best one by looking at the results. Then to that, you add another one. And likewise, you increase the variables and see whether the performance is increasing. If the performance is not increasing, you are not adding, right? So that you do. Then finally, you find what is the best combination to run. You might not need all of it. Feature selection is not selecting all the feature selecting is selecting the best possible features, right? So you can do backward elimination. That is, you start opposite of this. You start with all the features. Here we start with all features available and build a model. After that, you check and reduce the number of variables. And see whether it's increased. Likewise, it's the other way around. So you can do it using linear regression or logistic regression. You can do that. Okay, right. So that is wrapper method, students. Now, embedded method. Now read this one and see. These methods encompass the benefits of both wrapper and filter methods by including interaction of features, but also maintaining reasonable cost. Embedded methods are iterative in the sense that they take care of each iteration of the model training process, carefully extract the features, those which contribute to the most of the training for a particular iteration. So it's doing it itself, right? Now you are it's the checking performance, earlier one, checking performance, you take it outside and check it and run it again, right? Here it's doing it by, it is inside. The selecting the best subset is done by checking, and it's done by itself, right? That is, example is lasso and ridge regression. So it's doing it by itself, right? You are not going to check the performance and finding it out. It's doing it by itself. Is it clear, students? All right. So apart from that, you can use random forest also, students, to find out whether the what features are best. So here, what random for, anyway, you don't know decision tree yet, no? So what you can do is right. So we will discuss it later, right? This random forest, we will discuss it later. Why? Because in here, what in order to do this, you should know what is a decision tree, right? Random forest, what it is doing is it's finding out a lot of decision trees, and out of that you find what features are giving you the best results, and then you select these features. It is also a feature selection technique. Okay. Right. Let's go to feature extraction. I'll read this one. This is very important. Now feature selection is over. Now feature extraction. Read it and see. All right, so we are going to talk now about PCA. Now you understand, we discussed earlier what is feature selection. So feature selection, you find out what is the best features, right? Feature extraction is what you can do is you can combine few variables and you can come up with new variables, right? So here it says PCA is a linear dimension reduction technique that transforms set of correlated variables into smaller number of uncorrelated variables, right? So what you do is out of P variables, you determine K variables. K is less than P. That means here I have, let's say, 5 variables. I reduce it to 3. Like that's what you do. A principal component is a linear combination of original variables. So what you do is you combine the original variable. Here, these 3 is just explaining the process. principal components are extracted in a way such that first principal component explain the maximum variance in the data set. So what is more together, what is having the more impact on the data set? Together, but not correlated to other. There's two, let's say, few variables together. They are not correlated to the rest, but they are having a high impact on the target. That's how you identify. Second principal component, try to explain the remaining variance. You have the huge impact what is having set you selected together. Next set you select. Next set you select. Likewise, you go home, right? So if you go again, if I show you a small demo, you can see here. I will not go into code insurance. So here you can see so many variables are there. So many variables are there. You can break it into different components. So you can see, you can break it into even two components. Likewise, you can first principal component and second one. Likewise, you can get it. Okay. Right. So let's not spend a lot of time here. Okay. Now what we are going to discuss next, students, is normalization, data transformation. So data transformation, there are so many techniques. I will only discuss these three. Apart from that, this log transformation, binning, likewise, these things are also there. Right? So why do you need normalization and standardization? Why is that? So here it says normalization, what is it? Is rescale value into 0 and 1 range. Why would you do that? I think there was an example. No, it's in the next slide. So example is, student, I will give a different example like what is in the, not in the slide. So here, if you think about area of a land and price. Area you might give it in perch. Let's say perch you give 10 perch to 40 perch, likewise you give. Price might be something like a huge number. Something like this. So you can see this value is very small, this value is very large. In that case, when you run the data analysis, so definitely this will have a more domination over the analysis, right? So in that case, what you do, both of this you scale down into something between 0 and 1. That is standardization. Sorry, that is normalization. Okay. Standardization means everything you rescale in a way that it is, this is requirement of a data analytic techniques into mean of 0 and standard deviation of 1. You rescale down. That is standardization, right? So here it says when to use standardization or normalization. Data analytic techniques require range of all attributes of data set to be equal. Some data analytic technique you need that. For example, k-means if you have something like that, it will give you a different combination. If you rescale, it will give you different combination. So in that case, you might have to reduce it, right? So this will be needed, especially for algorithm in data analytics that use distance between data objects. Now k-means, for example, is a distance-based clustering. In that case, you will see when you come to next week lecture, right? So in that case, you might have to standardize. Okay. Then, normalize it. Normalize it. This is normalization. Data analytic techniques requires variance or standard deviation to be equal. In that case, you can use standardization. Example technique which might use it is PCA. Okay, right. How you do one technique to use normalization is given here. That is min-max normalization. There are other normalizers also. So you can see how you do the equation is also given. Example given is salary and GPA analysis. Now GPA is very small. Salary might be a large figure. So in that case, what you can do is you can do normalization or standardization depending on the technique you are going to use. So if you are using something like k-means, you have to do normalization. So if this is how you do min-max normalization. So you have attribute value, you deduct minimum of that range and divide by maximum minus minimum. That kind of thing you can do. Okay. So I'm not going to teach you the equation. We can try it out later. Right? Then let's look at transformation techniques. For sometimes you have students, as I told you, you can have categorical and numerical variables. Categorical variables are there, numerical variables are there. Categorical is like low, medium, high. Numerical is like height, weight, like this. Right? So there are techniques you can use to change this. For example, if you want to change numbers to categories, numbers into categories, you can use discretization. If you want to make categories numbers, you can use this ranking transformation and binary coding. Okay. So let's see what these are. Example is given here. Here is a categorical variable. So you have education level. High school is there, something like A level. Bachelor's degree, master's degree, doctorate is there. Right? So how you can encode this? Now you have to convert it to some techniques. You have to run it in the numerical form. How do you do that? Well, this is one way to do it. We call it as binary coding. There are so many ways to do this, right? So what you get is a matrix for each value. So you have here 4 different values. No? High school, bachelor's, master's, doctorate. You get 4 columns. And you put for this one, first row, if it is high school, mean you make it this one. Bachelor's mean you make this one. If it is a master's, you make this one. Doctorate, you make this one. Is it clear? So what you do is column, you convert it to a matrix. And this will be included in your data set. Is it clear, students? Is it clear? Or if there is an order, you can put it in the order. You can do a ranking. For example, usually your highest one is doctorate. So you have high school. Then you have bachelor's. Then you have master's. You have doctorate. So this is, let's say this is 1, 2, 3, and 4. So you transform using the ranking. So high school is 1. Bachelor's you put 2. Wherever you have doctorate, you put 4. Master's you have 3. So that is another way of encoding. Okay. This is another way I will show you at the end. Attribute construction I will show you at the end. So discretization the other way around. Numbers into categories. Of course, you can break it into different categories. So you know how to do that, right? So you can come up with ranges and you can put values into that. Equal with, you can say, of course, if you have, let's say, what do you call GPA, let's say, GPA, you can take, okay, GPA 0 to 1, 1 to 2, 2 to 3, 3 to 4, equal with, you could put how many are in this range that you count and find out, right? So you have to give a name for this. This is a category. Now we have 4, this is category. So high performers, likewise, you have to form categories. Then you put values into this category, how many, for 1 with 0 and 1, you put one name, label you can put, right? Like that, right? Or you can put equal frequency also you can put. That means if you find, okay, between, I have 100 students, I will say I have, okay, 900 students. I'm going to have them 300 each in one range. Equal frequent aims to have equal number of objects in each peak. So I'm going to break it into 3 set of 300, right? Depending on, I'm going to sort them by their GPA and put the first 300 here, second 300 here, third 300 here, and I'm going to have a category for them. That is equal frequency. Or you can find out cutoff point determined based on the knowledge about that. You can think about like, okay, from this point onwards, I'm going to put it in this class. That is like, you have to think and do it if you have knowledge. That is another thing. So what you're doing is, students, you are breaking this data into several parts, giving a category name, and in the data set, instead of the numeric value, you put the category value. That's what you do. Okay. So the last one is attribute construction. So attribute construction, here it says, use the knowledge about the original attribute to assume more accurate information about transform data. Attribute construction can, okay, the example is, you have this example here. Now you can give like more meaningful, rather than high school, you can put years of education. So by high school, you might have, here it says 12, let's say 12. 12 years you have studied. Then when you go to bachelor's, you spend 4 more, 16. If you go to master's, from here, you spend 2 more years, 18. If you go to do a doctorate, you can spend again 3 years or 4 years, 21. So what you do is this one you transform into education, number of years of education, and you have come up with a new column. So for these students, as it says, use knowledge of the original attribute and assume more accurate information. Rather than ranking it than 0, 1, 2, it gives more meaning. When you say 0, 1, 2, 1, 2, 3, 4, there's one difference. But you can see when you say bachelor's and doctorate, there's like 2, 3, 5 years difference, right? So that will give you more information, right? So then another thing is, another way to construct attribute is by combining more than one attribute. For example, using height and weight, you can develop BM. That you can do, okay? That kind of thing you can do, right? Okay, that's the end of the students. But before we go to end, let me summarize what we have done, right? So what we have done is, we have our lecture is data pre-processing and feature engineering, right? Feature engineering, right? So we talked about data pre-processing. We will take all of these under data pre-processing as well. So we talked about missing values. Right? Then we talked about outliers. Right? Then we talked about what do you call data reduction. Data reduction, you know. Now we discussed technique for this also. Missing value. You can remove the row. You can remove the column. You can impute value. You can do nothing. Outliers, we again did. You can delete the outlier, you can keep the outlier, or you can bring them into upper and lower bound that we discussed. Then data reduction, we talked about numerosity reduction. Here we discussed 3 sampling techniques: random sampling, stratified sampling, and O and undersampling. Random, O and undersampling that we discussed. Then we talk about dimension reduction. These two are for different reasons. Numerosity reduction is to now reduce the number of rows. What's the purpose of both of these is to reduce the computation cost. This is to reduce the number of rows. This is to reduce the number of attributes or columns or features. Dimension reduction. Here we talked about 2 things. Again, let me take this out. You can't see it. I have another window there. Right, dimension reduction. We talked about feature selection and feature extraction. These are 2 things. Feature selection, we talked about filter method, wrapper methods, and embedded method. Apart from that, we discussed random forest rows. Feature extraction, under this we discussed PCA, right? Then another thing we discussed is transformation, right? We talked about how you can convert data into numerical to categorical and categorical into numerical, right? So that is conversion between categorical to numerical techniques we discussed, right? So what are the techniques? We talked about attribute, ranking transformation, the numerical, the binary encoding, and what is the other one? Attribute construction also you can use. Okay. transformation. Then we talked about another thing. What is that? Discretization. Discretization is also, you can be taken as a technique like this. Okay, is it clear, students? What we have discussed, is it clear? Is it clear? I don't know whether it's clear to you. I think it should be clear. It might be a little boring because it's a theoretical lecture, but we will do more computation from next week. Okay, is it clear, students? So that this is the end of the lecture. Right. Only one